Welcome to the Environmental Health and Safety Virtual Classroom. I'm your instructor, Derrick A. I'm an environmental consultant and industrial hygienist with over 27 years experience in the recognition, evaluation, prevention, and control of hazards in the built environment. In this session, we will be discussing mold. In this session, we're going to answer some of your burning questions, such as, what is mold? Why does mold grow indoors? What are the health effects associated with mold? What are some mold myths? What are the regulatory obligations? How about prevention strategies? How about response tactics? What are mold assessment tools and techniques? And furthermore, what are some important mold resources you can look to? So, what is mold? Well, molds are microscopic organisms, and they are ubiquitous to their environment. They're everywhere. You've all seen mold growing in a shower. You've probably all seen mold growing on bread in your cupboard. Molds are everywhere. In fact, in a cubic meter of air in my hometown, Phoenix, a box of air about that big, there's about 1,000 mold spores floating around. Now, you and I can't see them with the naked eye, but they are floating around, along with all the other things that are in air, such as pollen and insect parts and particulate matter, such as silica dust. Mold spores float around, and they are essentially seeds. And those seeds land on surfaces. They land on the book. They land on my hair. They land on the table. And they're waiting for the right conditions to grow. Once the conditions are met, the mold spore will grow into a mold colony, which will be essentially like a big circle. Sometimes those circles will intersect. And when those mature molds reach a certain point, they will then create their own spores and send those out into the atmosphere to land on books and land on tables and land on my hair and continue the process. Why does mold grow indoors? There's three basic requirements for mold growth in the built environment. The first one is atmosphere. Mold needs oxygen, and mold needs a temperature range that you and I can live in. So you can make a building too cold for mold to grow, for example. That's what we call the freezer. And you can make a building too hot for mold to grow, but it's really hard to do work in buildings that are that hot. You can make a building devoid of oxygen. For example, in a flood, when the flood waters come up over your head, no mold is going to grow, but it's also difficult to type underwater. So atmosphere is a mold requirement, but it's difficult to alter in the built environment. The second thing that mold needs to grow is a nutrient source. Molds eat organic material like paper on drywall, bread in your cupboard, even skin cells, dust, pollen, anything organic mold will eat. So you really can't change that in the built environment. Even if you got rid of all the organic building materials, for example in your shower, you still will get mold growing on tile, glass, plastic. Mold can't eat those things. Mold is eating the biofilm, the dust that has settled on those things. So nutrient source control is really not the requirement that you want to focus on. The third requirement for mold growth, besides atmosphere and nutrient source, is water. Mold needs water to grow. All living things need water to grow. Water control is the key to mold control in your structures. So if the conditions in your building allow for the growth of mold, how will you know? Well, sometimes it's pretty obvious. You'll see mold colonies growing on your walls, on your cabinets, on your ceiling tiles, on your shoes. But sometimes mold hides. Mold likes places that are dark and wet. It doesn't like UV interruption. Molds like places where there's not a lot of air movement. So when your air conditioning turns on or you have your ceiling fan on, it tends to dry the surface that you can see and touch. But the surface that you cannot see or touch tends to remain wet longer. Contents often obstruct visible mold growth. So you may have visible mold growing behind a table, behind a cabinet, behind a refrigerator that you might not be able to see. You could have mold growing inside a wall cavity or under your millwork. So sometimes you'll be able to see the mold, obviously in an area where it's unobstructed. But there are many times where mold can be growing in your building and it is hidden. Let's talk about the health effects of mold. There are 4 basic mold-related health effects. 2 are very common, and 2 sound really spooky. The 2 common ones are irritation. Irritation of the eyes, nose, causing you to sneeze. All molds can be irritants. Also, all molds can be allergens. Allergic responses can be something like headache, lethargy, asthma trigger, itchy eyes. Allergy is the most common response to mold. Depending upon your allergic profile and depending upon the types of mold you're exposed to, you may or may not have an effect, a health effect. You may or may not demonstrate some sort of symptom. It's not uncommon for us to be in a building where there are 2 people sitting side by side exposed to the same mold, and one is having a really tough time staying in that environment and the other one is just fine. That's because everyone has a unique allergy profile, but all molds can be allergens. Some molds can infect you. Ringworms, athlete's foot, jock itch, aspergillosis. These are all fungal infections of the body. Some molds can intoxicate you. If you go to a bar, the single cellular fungi, yeast, has produced alcohol. And if you go into a bar and you are standing there inhaling alcohol from people's drinks that have evaporated, you're probably not going to be intoxicated. You are having exposure, but you're not having a dose that makes any meaningful impact on your life. But if you drink tequila, that's how you get into trouble with alcohol. Alcohol is a mycotoxin, so some fungi produce toxins and they can intoxicate you. How does mold reach your body? Well, hand-to-mouth transfer. You can touch moldy surfaces and touch your mouth and get mold exposure. You can touch a surface and have dermal absorption where it goes through your skin. You can inhale mold-related gases, or you can inhale mold-related particulates. So I mentioned in earlier sessions that molds are everywhere. Molds are ubiquitous. In the air that I'm breathing right now, there are mold spores and mold hyphal fragments, and I'm inhaling mold mycotoxins. I'm inhaling all kinds of particulates. I'm touching them. They're on the surfaces. I'm having an interaction with mold every day of my life, as are you. So what makes an acceptable environment versus an unacceptable environment? Generally speaking, your authorities on mold, EPA, World Health Organization, IICRC, AIHA, etc., all say about the same thing. There should be no visible mold growth in your building. Visible mold growth is defined as mold that's grown to a quantity that you can see with the naked eye in both accessible locations and obstructed locations. If you have visible mold growth in your building, it warrants a response. It doesn't mean it is unsafe, but it has the potential to cause more mold exposure than background, which has the potential to increase health effects. The second criteria is that the air inside your building should be similar to the air outdoors. The mold concentrations in the air should be about 1,000 mold spores in Phoenix. Now, some days it's about 50 and some days it's 5,000, depending upon when it rained and how much wind we have. But if you go to a place like Portland, Oregon or East Texas, their background concentrations of mold may be 40 or 50,000 spores per cubic meter. Does it mean it's unsafe to go to East Texas? No, not for mold. You might have an allergic response because you may be susceptible to allergies, but what you want to make sure is that there's no visible mold growth in your buildings, and you want to make sure that the air inside your buildings is as good or better than the air outdoors when it comes to mold, both quantitatively and qualitatively. What do I mean by that? Qualitatively, they should be the same numbers. If it's 1,000 outside, it should be 1,000 or less inside, ideally. And quantitatively, what types of mold are growing? If it's aspergillus outside, it should be aspergillus mostly inside. If it's penicillium mostly outside, it should be penicillium mostly inside. That would be considered an acceptable environment. That may or may not be healthy for your population. If your population is immunocompromised, for example, a chemotherapy patient or an organ transplant patient, or someone who's undergoing a bone marrow transplant, they may be placed into a facility that is cleaner than outdoors because they need less mold exposure than background. What are some myths and misconceptions surrounding mold? Let's start with mold-free. Your occupants may say, I want a building that is mold-free. Well, that, my friends, is not possible. As I mentioned, mold spores are everywhere, in the air and settled on all surfaces. So there's no such thing as a mold-free building. There should be a building that's free of visible mold growth, and the air inside the building should be similar to outdoors. Dangerous molds versus safe molds. All molds can be irritants, and all molds can be allergens. And for that reason, there's no such thing as a safe mold. An allergic response can be as severe as an asthma trigger. And so safe is not a term that you would use for mold. Black mold. Black mold is a very common term used in media. Many molds are black. Some molds are orange. Some molds are yellow. Some molds are green. The color of mold really has no indication on the potency or impotency of that mold. So if you are exposed to black mold or green mold or blue mold or whatever mold you want to pick, it's unacceptable if it's visibly growing in the building or you're receiving more than the background concentration. Black molds are not more dangerous than other molds. Dead mold versus live mold. Why don't we just heat mold in place? Why don't we just bleach mold in place? Why don't we just dry mold out and let it naturally die? Well, that's because dead molds and live molds both have similar health effects. If a mold is dead and no longer able to grow or replicate, it can't infect you, but it can still be an irritant, it can still be an allergen, and it can still intoxicate you. So what are some mold prevention strategies for your built environment? Well, the key, again, is water management. We want to make sure that if you have a leak, you address it immediately and properly. You want to pick building materials that are mold resistant or water tolerant. You want to pick building materials that don't inhibit the evaporation of water. An example might be vinyl wallpaper. Vinyl wallpaper looks really nice in a hallway, and you can wash it. It prevents water from going into the drywall. Conversely, however, if there's water inside the drywall, it cannot evaporate through the vinyl wallpaper, and it traps that moisture inside of the wall. Other mold prevention measures might include using tools to identify things that are wet early. For example, infrared cameras, moisture meters, thermal hygrometers. So what do we do if we have a mold problem in your building? Let's talk first foundationally. The mold spores that are settled on this book are what we would call condition 1, normal fungal ecology, normal loading of mold spores and fungal material in the environment. That's what you're after, not a sterile environment. Condition 3 on the other end of the spectrum is the visible growth of mold. If there's condition 3, visible mold growth, it requires some sort of cleaning or some sort of demolition. Condition 2 would be if there was visible mold growth here and an abundance of mold spores or mold particulate landed on this book. You would need to clean this book to bring this back to condition 1 or normal fungal ecology. So if there's visible mold growth on materials, we're going to break these materials down into 3 categories. Porous materials, like this book, like drywall, like carpet. Non-porous materials, like plastic or metal or porcelain, and then semi-porous materials, which would be things like structural wood. If there's mold growth on a porous product, visibly growing, you would remove and replace that. So if you have visible mold growth on your drywall, there's no cleaning, you remove and replace the drywall. If you have visible mold growth on your t-shirt, you would remove and replace that t-shirt. On the other end, non-porous materials like your toilet made of porcelain, if you have visible mold growth on your toilet or in your shower, you would clean those surfaces. Wet wipe, HEPA vacuum, etc. And then semi-porous products like wooden structural members, you would basically abrade or remove the top millimeter of those materials. Wooden studs, for example. If you have an item that doesn't have visible mold growth on it, but it has an abundance of mold spores because visible mold growth was happening nearby, you would break those products down into 3 categories: porous, non-porous, and semi-porous. Porous materials, like this book, can be HEPA vacuumed or wet wiped if there was an abundance of settled spores. Non-porous products, like metal, glass, porcelain, plastic, can be wet wiped or HEPA vacuumed as well. And semi-porous products like wood, structural members, can be HEPA vacuumed or wet wiped as well. There are some products that are not compatible with HEPA vacuuming and wet wiping. Those might be things like paintings. It's not uncommon for people with mold growing in their buildings to default to the use of disinfectants. Disinfectants have consequences. Disinfectants or growth inhibitors associated with mold also may injure or damage people or your building. For example, lead-based paint is an excellent growth inhibitor, but no one would argue that lead is bad for people. When you bring a chemical into your situation, you're going to need a safety data sheet. And if you look at the safety data sheet on any of these disinfectants or growth inhibitors, they will frighten you, they will frighten the people who read them. Importantly, you don't need chemicals to control mold. Remember, mold has 3 factors that need to be present for them to grow. 1 is the right environment, 2 is the right nutrient source, which you can't really control, and 3 is the management of water. So you need to manage water. You don't need to apply a chemical to control mold growth in your building. When people discover the growth of mold in their building, they often want to have it tested. What kind of mold is it? Is a common question. It really doesn't matter what kind of mold you have. All molds require a response. If visible mold growth is in your building, or if the air in your building is not similar to outdoors, you should do something. You don't need to necessarily test to find out what kind of mold it is. If there's visible mold growth, you should address it. But there are ways to test for mold. One way is on surfaces. Surface swabs, for example, tape lifts. You can find out what kind of mold is present, if that answers a question for you in your facility. You can test the air. There are tools to test the air to find out how much mold is in the air at this time. But testing is not required to determine a response. Another important thing to know about testing is air testing is usually the default. And air testing is a powerful tool, just like all tools have a place. But the mold in the air tells you only for that 5-minute period or that 10-minute period or however long that sample is collected about the mold that's in the air. It would not be uncommon to have visible mold growing on this table and to collect an air sample and have no indication that there's mold growing on that table. So looking for mold, investigating for mold requires a multi-pronged approach. Find out, do I have a history of water damage? Is there anything that exhibits rust, staining, swelling, delamination? Or is there visible mold growth that I can see? You can also do air sampling to supplement that in case there's something that is hidden. But don't just default to testing. The question that people often ask is, what kind of mold is it? If it's visible mold growth, it warrants a response. The United States Center for Disease Control and Prevention, or the CDC, the Institute of Medicine of the U.S. National Academy of Sciences, the World Health Organization, or WHO, the IICRC, the AIHA, the Indoor Air Quality Association, etc. All are in agreement. Living or working in a building with mold damage results in an increased risk of respiratory disease. There are no accepted national or international standards for mold investigation, evaluation, or remediation. There are, however, several guidelines that do exist. Keep in mind that OSH 1970, which is a U.S. regulation that created OSHA, has a general duty clause, which in a nutshell says, don't expose your workers to a known hazard. Mold is a known hazard. The US EPA has a guidance called Mold Remediation in Schools and Commercial Buildings that is often a go-to for people who are dealing with mold in their buildings. The IICRC Standard and Reference Guide for Mold Remediation and the AIHA Recognition, Evaluation, and Control of Indoor Mold are also common texts referred to by industry professionals. In this session, we've covered a lot of ground, but we've barely scratched the surface when it comes to mold. We discussed what is mold, why does it grow indoors, what are the health effects associated with mold. We talked about some common myths. We discussed regulatory obligations, prevention and response tactics, mold assessment tools, and we talked about some important mold resources. Now that you have the foundation, go forth and learn more about mold. If you haven't had mold growth in your building before, it's not a matter of if, it's when, and you want to be well prepared. That concludes this session of the Environmental Health and Safety virtual classroom on mold.